For part 1, to find the frequency in terms of m, q, and b, I used three definitions of frequency right here. And I set these two equal to each other, which gave me that. And I solved for the radius. And I solved for the radius for the first frequency also, and I set those two equal to each other, which is right here. And then I solved for frequency for that equation. So for part 2, I took the circular motion description given above, and I substituted the formulas found in part 1 for frequency and radius. Just the radius one and the frequency one. And because m, v, q, and b all equal 1, and the 2 pi's cancel out, the circular motion simplifies to just this right here. And because I need to take into account the z component, I also have to find an equation for that. So I know that the z direction is dictated by velocity, so you can just use the formula for vf to describe z, which would just be z equals vo plus 1/2 at squared. And we know that the particle starts with a velocity of 0, so vo just goes to 0. And in order to find acceleration, I used two equations that define force, and I set them equal to each other and solved for a. This shows me that a just goes to 0 also, or just goes to 1 also, because q, e, and m all equal 1. So that simplifies this equation to z equals 1/2 t squared. So then when I plug that into Wolfram alpha, I used an upper limit of 5 and a lower limit of 0, which gave me this curve here.